Okay, this is the second video talking about division or polynomial division and how it can help us as far as finding zeros and factors of polynomials. So this is kind of the main idea. A new method of factoring or repeated division. If I have a big polynomial like the one up top here, let's say that this polynomial was equal to f of x, right? And I want to factor this polynomial. If I know what its zeros are, right, then I can write factors. So such as over here from the graph, identify all zeros of the function. Well, I know that I've got a zero at x equals -3. Looks like I have another zero at -1, and we've got a final zero at 2 over there. Now I can't really tell if that one at -1 is kind of wiggling through there. It might be a triple zero, it might not be. But my thought is, okay, if I've got at least 3 of them, one thing that I can do is use those zeros to repeatedly factor, repeatedly divide, essentially, them out of that original polynomial. So let's just start with the first one. I'm going to take that -3, and it's a perfect time to do some synthetic division. 1x to the 5th, 2x to the 4th, minus 4x cubed, minus 4x squared, minus 5x, minus 6. And again, the nice part is we weren't missing any terms, so no zeros in there. But we'll drop that 1 down, multiply and add, right? Multiply by that -3, add them up to -1. Multiply by -3, again adds to -1, times -3, add them up, and times -3. And because I knew it was a zero of my function, I fully expected that remainder to be 0. So that's a good sign that it came out to 0 there. Now, if you think -3 is possibly a double zero or a triple zero, you could try that again. But since I already know I've got another 0 to work with, I'm going to go ahead and divide again. I'm down to x to the 4th now, right? Our exponent went from x to the 5th up here down to an x to the 4th term. But why not go farther? Why not take it a little bit farther here? If we use our -1, another one of our zeros, I'm going to drop down that leading 1. Again, multiply and add, multiply and add, multiplying by -1, adding it up, multiplying by -1. Again, 0 remainder, because we knew that it was a 0 of my function. Also a great way to verify if something's a 0 or not. Maybe we thought it was -1, but maybe it wasn't exactly -1. Well, we just verified 0 remainder. It's definitely a 0 of my function. So let's try that with our last one here. We know that, or we think anyway, that 2 is another 0. So let's do it one more time. I'm going to drop down that 1. Makes for 2 is 0. Again, multiplied by 2 is 0. And multiplied by 2 is going to add to 0. So again, all 3 of those definitely worked out. They were definitely zeros of my function. Now we also just went from x to the 5th up top here, right? That first one, down to an x to the 4th, x to the 3rd, and this last one down here means that we're now down to x squared, right? Plus 0x's plus 1. And because that's not really factorable, right? Not without imaginary numbers anyway. Since that's not really factorable, what I can say is that f of x would factor into, well, we're going to have x plus 3 from that -3 over here. We would have an x plus 1 from our -1. X minus 2, remember that our factors are always x minus the zeros, right? And then finally, because x squared plus 1 doesn't really factor as we would normally factor it, we will just leave that as x squared plus 1. Again, if that was more factorable, we could take that apart as well. If it would have been a -1, let's say, we definitely could have factored that x plus 1, x minus 1. But because it's not, we're going to say that we're fully factored here. And that looks pretty darn good. Excuse me. Let's go ahead and do that one more time. We've got our graph over there at the left, and take advantage a little bit. Notice we may have some multiplicity going on here. This bouncing 0 here, right, bounces off the axis. I'm thinking that 0 might just be a double 0. So we might have some luck there. Now, it's not necessary that we necessarily use it, because again, we're x to the 4th. We should only have 4 zeros. And we've definitely got 1, 2, and hopefully 3 of them on here. So there should only be 1 left over. So let's go ahead and get to work here. Again, we've got -3, -2. It looks like +1 over here. So let's start with negative 3. We're going to plug in 1, 3, negative 3, negative 7, and 6. Notice again, no terms missing. I'm going to drop down that 1. Makes for negative 3. 0 is 0. Adds up to negative 3, which multiplied again by negative 3 makes 9. Adds up to 2, multiplies to negative 6, and we get that 0 remainder like we expected. Right? Now, I'm going to go ahead and jump over. I'm going to use that 1 from that double 0. Okay? I'm going to go ahead and do that one first. I'm going to take that 1, drop it down again. Multiplies and adds, multiplies and adds. It's always nice when it's a 1. Multiplying and adding, pretty easy there. Now, we have two options here. If we think that's a double 0, we could try plugging in 1 up here and see what it comes out to. Okay? Which again, we could do very quickly. 1, 1, 2 is 2, and 0. And it turns out it is a double 0. Okay? But now if that didn't work out too well, we'd be kind of stuck there. So what's better is to use what you're a little more sure of. I'm going to go back here and I'm going to go ahead and put in that negative 2 that I thought was a 0. It looks much more confidently like a 0 to me. And you'll see very quickly, again, drop the 1 is negative 2, negative 1, positive 2 is 0. And notice what we end up with. We went from x to the 4th, to the 3rd, to the 2nd. This is actually x to the 1st minus 1. And if we were looking for the 0 of that leftover function, I could set that equal to 0 and x equals 1. Again, that double 0, right? We got the first one up here. We got the second one down here. It turns out it was a double 0 anyways. We would have figured that out either way. In that case, again, we wanted to write the factors, not the zeros, right? If we were listing off the zeros, we would simply have said negative 3, negative 2, and 1, although noting maybe that 1 was a double 0. Instead, I'm going to write the factors. So we've got f of x is equal to, again, we've got an x plus 3. Because there's a negative 2, we would say x minus the negative 2, or basically x plus 2. And then finally, we've got x minus 1, but because it's a double 0, we're going to go ahead and call that squared. That one's in there twice, which again makes for the fact that we've got our 1, 2, 3, and 4, right? Zeros all represented. We've got 4 possible zeros, and we accounted for all 4 factors. I hope that helps you with maybe a little bit of synthetic division, but mostly with finding zeros, as well as finding factors of a polynomial. Good luck, and if you have any questions, make sure you talk to your teacher. Have a great day.